Okay, it's recording again. All right, so the problem with learning just pi over 2 and pi over 4 and pi over 3 and pi over 6 is you're kind of learning only half of what we think about in the world going around. And so um, you really, if you think about it the way that's taught, try to do it this way, you're leaving out 15 degrees and 75 degrees. And so mathematically, when you're playing around with that circle and kids are discovering it, that's probably one of the most obvious ones to do when you look up at the sky and go out early in the morning or early in the evening and looking how that sky turns 15 degrees. So we're left with that quandary of learning why not teach that, and I guess it's because it's not convenient. That's the best I can do, and that's coming from a pretty insightful student. Why not 15 degrees? So at the risk of not being able to recount pi to so many places as some kids can do, I'm going to just tell you that basically the cosine of theta over 2 is equal to square root of 1 plus the cosine of theta all over 2 inside the square root. And the sine of theta over 2 is the square root of 1 minus the cosine of theta over 2, all in the parentheses. We'll put that down below. And that seems like pretty complicated. We also can then realize that if we know one number in a cosine-sine pair, we can use Pythagorean theorem to solve the other. And if we know 15 degrees sine and cosine, we know 75 degree sine and cosine by some little mathematical trick called symmetry, which was introduced in everyday math probably around 3rd grade. So I'll give you one number because it's the only one I got, and the other one is just escaping me all the time. And that, in fact, is the sine of 15 degrees is 0.2588. Or, if you want, the square root of the quantity 1 minus the cosine of 30 over 2. But the sine of 15 degrees, or in fact on the unit circle, the value of the y at 15 degrees is 0.2588. And so now you know every 15 degrees or every hour on the unit circle, and you're prepared to now start applying this on a regular basis, not just for shooting your buddies in Call of Duty or making Mario Brother go up and down, but to apply it to something called transformations. So to do that, you then have to step into this concept from the lattice method of number value or place value that goes beyond ones, tens, hundreds, thousands, 10,000s, 100,000s, millions on up the place, or back the other way to tenths, hundredths, thousands, 10,000s, 100,000s, and millions. So that's where it goes, and we'll see what we can find out on the web to get you to this next little bit. I'm going to look for someone talking about 15 degrees, and otherwise I'm going to have to make my own. Thanks for listening.